Welcome to LabMinutes.com. In this video, we'll be looking at some advanced functionality of NAT. The first one on our list is port forwarding. Port forwarding is very similar to a one-to-one static NAT, where you can make services on the inside or hosts on the inside available to the outside. But instead of having one dedicated IP mapped to one inside IPs, port forwarding actually allows you to map multiple services on the inside to a single outside IPs. Port forwarding is very handy when you only have one outside IP available. For example, in a small environment where you only have one public IPs on your internet routers. So in our lab here, we're going to try to make two services on the inside available, which is a telnet on IP 32.32.32 and a HTTP on 32.35, and allow that accessed through a single IP, which is 111.252 on our outside interface of the router R1. So let's start on our config. First, on router 1, we're going to enable NAT on the inside, IP NAT inside. Just wait for that to come back. And then we're going to enable IP NAT outside on the FAS01. Okay. For the port forwarding, you can actually choose the original port or you can have the original port and the mapped port to be in the same port number if the port that you want to map is available. But obviously with the single IPs you have available, if you need to map to multiple services that use the same port, it's not possible to use the exact same port on the outsides. In that case, you're going to have to use an alternative ports number. So here we're going to map telnet port 23 on the switch 1 loopback 0 on the inside to port 2323 on the outside. So IP NAT inside source static, and if you look at the option, there's a TCP option, and then its local IP address is the loopback 0 that we use to emulate a host, and the port of the service, which is TCP 23 for telnet, and the outside IPs, instead of mapped to any IP of your choice, we're just going to map to the interface IP. In this case, which is FAS01, and here we're going to choose port 2323. Okay, the second service that we're going to make available to the outside is the HTTP on the .35 loopback 1 switch 1. Inside source static TCP 172.16.32.35 23 actually 80 interface FAS01, and we're going to choose 8080. Okay, here from R2 we're going to test telnet 111.252, start with the telnet, and here you can see it lands on the switch 1. And if you look at R1, show IP NAT translation, you can see the session coming from 1111, which is R2, with the inside global of port 2323 mapped to port 23 on the switch. Okay, next we're going to try port 8080. And since we're not really running an actual HTTP server, a web server on the inside, but at least you can see the port or the session came back as open with some headers. Let's do that again and take a look at our translation table. And here you can see an incoming port 8080 gets mapped to port 80 of the IP.35. So now we have successfully allowed both services to be accessed through a single IPs. Sometimes port forwarding is actually better for your security because you do not need to open every single available ports to your inside host, in which case that's going to require ACL or access list. But with the port forwarding, it's only those ports that you allow open or access in the NAT translations can be accessed from the outside, and any other ports is of course not going to be able to be accessed. Okay. The next feature we're going to look at is the destination NAT. So instead of just translating the source IP, we were trying to translate the destination IP. So let's say for some reason, let's look at this setup right here. For some reason you want the IP, outside IP 3.3.3.3 to appear as on the inside as 172.16.33.32. So we're going to have to NAT that IP to an inside IP using destination NAT. So when the switch 1 is trying to talk to the R2 loopback, instead of using the actual IP, you'll be using the NATed IP, in addition to the source IP that's going to be translated as well. So let's try that. But first, let's delete what we did in our last task. Okay, now we're going to do IP NAT. So first start off with natting the source IP, source static. Still going to be using switch 1 loopback 0. And we're going to NAT it to 111.32. In addition, we're going to do a outside source static 3.3.3.3 and NAT that to an inside private IP of our choice, which is 33.32 in this case. Okay, at this point, if you look at R1, R1 has no idea where I should send the traffic that has the IP for a destination of 33.32. You can see it says subnet not in table. So we need to add a static route to tell the router that, or any packets that has that IP in the destination field, we want to force it to be sent to the outside. Let's just do a single IP, and we'll make it the next top of the outside 1111 interface. Okay, so now on the switch 1, we're going to be testing with our ping. Before we do that, let's enable debug IP ICMP on our R2. We'll ping from switch 1 172.16.33.32. Okay, so let's see what's, source, of course, source loopback 0. Let's see what we've got here. Looks like we did not have a loopback configured yet on R2, so let's create that real quick. Okay, let's try that again from switch 1, and here you can see the ping succeeds. So from the switch 1 perspective, the loopback of R2 3.3.3.3 appears as the IP 172.16.33.32, and that was achieved by doing this destination NAT. Okay, you can see the source IP is still NATed to 111.32 as being seen by the R2. Okay, so the next feature we're going to look at is what's called NVI NAT, or what I usually call directionless NAT. So with the NVI NAT, there's actually no concept of inside or outside. So before, with the NAT inside, NAT outside, the NAT translation happens before or after the routing, depending on if you're going from the inside to outside or outside to inside. But with the NVI NAT, the translation itself actually happens after the routing has already occurred. So we're going to demonstrate the NVI NAT with our same scenario here. So first, with R1, let's remove what we had. Oh, also, just to show you, although R1 before R1 did not really know how to get to the R2 loopback 0. So you can see if we do show IP route 3333, you can see it's not in the table. And look at the static, it's not in there at all. However, R1 still know that after its translation, the packet needs to be forwarded to R2, and that's because the fact that we put a static route for the 33.32, which is the NATed IPs, with the next hop of R2. So R1 doesn't really need to know how to route to 3.3.3.3. Okay. We're going to see that's not the case when we use the NVI NAT. So let's see. Okay, we remove that, and then under the interface, let's remove no IP NAT outside. Oh, actually inside. Okay. Instead of that, we're going to put IP NAT enable on both FAST00 and FAST01. And on the outside, IP NAT enable. So you can see they look pretty much identical. There's no direction involved for being inside or outside with the NVI NAT. And then on the IP NAT command, instead of do IP NAT inside or outside, it's just going to be IP NAT source static 172.16.32.32 going to 111.32. And 3333 going to 172.16.33.32. Again, there's no indication of there's no embedded information as far as the direction whatsoever. It's just basically said if the source IP is this, it will be translated to this, regardless of which direction it's coming from. So now, if you try with the switch 1 and do a ping again, see it's not going through right now. And if you look at R1, it's complaining something about looping packets detected. And the reason being, R1 doesn't know how to get to R2 loopback interface, unlike earlier where it doesn't really need explicit static routes or routes. But here with the NVI NAT, this is a requirement. So in addition to the static route to our NAT IP 33.32, you also need an IP route for the actual IPs on the outside. Here, telnet is on R2. If you ping, now the ping went through successfully. And you got the source NATed properly, as well as the destination. So switch 1 has no idea that it's actually talking to 3333. If you look at the R1, do show IP NAT NVI translation. So the inside IPs get NATed to the outside source IPs 11132. At the same time, the destination inside 33.32 is NATed to 3333. Okay, so NVI NAT sometimes makes your life a little easier, or it's a little more flexible, because sometimes you might need the inside and outside to be in the same interface. I'm not sure if that makes much sense, but by not having to depend on the direction on the NAT statements, it makes the whole configuration in some situation a lot more flexible. Okay, so now I'm just going to move on to the next scenario, or next features, is TCP Load Balancing. So with TCP Load Balancing, what it allows you to do is, if you have multiple identical services on the inside, you can have that mapped to a single outside IPs. So when that IP is accessed, the router will be able to load balance or redirect the traffic to each of the available services in the round-robin fashion. The downside of this obviously is R1 doesn't know the liveliness of those internal services. It's just going to blindly forward the traffic to the inside. There's no keep alive or anything check. So there's a chance that if the inside or internal services are down, then you're just going to be sent to a service that's not available. So here we're going to have switch 1 loopback 0 and switch 1 loopback 1 emulating to internal services, and then we're going to have it mapped to a single outside IP of 11132. And again, we're just going to play with telnet. So with that, let's remove the commands that we put in earlier for that. So no. Okay. IP NAT outside, no IP NAT enable. IP NAT inside, and no IP NAT enable. Okay, so we're back where we were. Now we're going to do IP NAT. So we're going to create a pool, and the pool is going to consist of the IPs of the services we want to make available. So IP NAT pool, we're just going to call it NAT server. No, NAT. You're just going straight to prefix 24. So you can either give it a range or a multiple discontiguous range. Here goes address 172.16.32.32. Again, I'm just going to do 172.16.32.32, and then address 172.16.32.35, and again 32.35. Next, we create access list. Let's just call it NAT, then permit IP coming from any going towards NATed IPs, 32, and last we're putting them together into a single NAT statement. We're going to do IP NAT insight, but since we're manipulating destination in the sense of the request packet coming from the outside, we're changing the destination IPs of the NATed IPs to the true host IPs. Match it to the access list, and then pull our pool that we created that contains the two server inside. Looks like we missed a command. Actually, if you go up here, that's supposed to be type rotary. Oh, looks like it doesn't like you to do that, so let's recreate real quick. Type rotary, and then it's very nice with the secure CRT. You can hold down the alternate key, and then you can copy multiple lines just like that, and then you can copy and paste. Just a little trick I thought I'll share. So that is created, and then we just redo the NAT command. Okay, so that's done. Alright, so here we're going to test it from R2. Telnet 111.32. Okay, so that's went through. If you look at the translation table again, you can see the telnet landed on 32.32. Okay, so let's try and disconnect and reinitiate the telnet session. Again, hit just fine. Come back to R1. Take a look. You can see the second attempt landed on 32.35. So the R1 essentially redirected the packet back and forth between the two IPs. So let's see what happens if we shut down one of the loopback and simulate the service down, a host down. So we're going to do that loopback 0, since we know that the next attempt is going to try to send it to loopback 0 of 32 IPs. Exit. Telnet, you can see it keeps trying. And that's because R1 has no idea that the loopback 0 is currently down. And that's basically the downside of this feature. Okay, let's put that back. Alright, let's clean that up real quick. Okay, so the last features we're going to look at is Multihomed NAT. So it allows you to do, for example, if you have a router or an internet router that connects to two separate ISP, and you want it to be able to fail over from one to another if the first ISP fails, and obviously the IPs that you need to NAT your traffic to has to be NATed to the IP that's allow or assigned by one particular ISP. So if it goes out the first ISP, it has to be NATed to the first ISP IPs, and so on and so forth with the second ISP. So here, the way you do that is with route map. So on the router R1, we have two outside links configured. One is on FAST01, it's the one we've been using for the whole time. The second one is on the serial 0000. So just to make sure the second link works, ping. Okay. So our goal is we're going to use the FAST01 as our primary connection, and for some reason that path becomes unavailable, then we're going to fail over to their second interface. And the way to do that, let's see, show IP route. And we're going to use the R2 loopback interface to test, although it doesn't really show in the diagram. Let's show up here. We already have a static route for 3333 from our previous scenarios. We're just going to add one more, 3.3.3.3. Here we're going to make a next hop to the IP in the second link. And we're going to make an administrative distance. Let's just use 240, so it's worse than the first static routes. To show IP route, still pointing to static. So still pointing to 1111. Okay, first we're going to create an access list that will match an interesting traffic. Here we're just going to do the whole subnet of 32, inverse mask, any to any. Yep. Next we construct our route map, just call INET1, match IP address, the access list we create. Also we're going to match and interface, so we're going to tell if it goes out the interface with fast01. Okay, then we're going to create the second route map called INET2 permit 10. Again, match IP address NAT, match interface serial 0. Okay, next we do IP NAT inside source route map INET1, so match not just interesting traffic, but also the interface that we're trying to exit, and we're going to NAT it to the interface IP with overload, so it's a PAT. Same thing with the second path with route map INET2, interface 0, 0. That's supposed to be overload. Okay, so we have both in there. Now let's try. So switch 1, ping 3333, source from loopback 0. And the R2 is seeing packet coming from the first link IPs, which is 111.252. Okay. Also shows on the translation table. Now we're going to shut down fast01. Show IP route static. And I can see the router picked up the second route, or the floating static route that we put with the AD of 240. So switch 1, ping again. Let's see. It's coming out as the actual IP, so let's see, what do we miss? Got our two route maps, the serial 0. Looks like when we create the interface, we did not put a NAT statement. There you go. So IP NAT outside, and let's try that again. Now you see it went out successfully once we've activated the NAT on the serial interface, and now the R2 sees the packet coming from 222.252. Okay, let's bring the interface back. And again, in real life scenario, you might not be able to rely on the physical state or physical down state of the interface to take away the route. You might need to do some kind of IP SLA to track the internet connectivity and tie that to the default route that will utilize the first path. So once the IP SLA has gone down, it will remove the route and then fail over to the second backup path. Now that our first interface is up, try ping one more time, and now we're back using the first link. And so that's it for the advanced NAT features. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.